Okay, so number 7 here. So yeah, a bunch of algebra. I'm going to give myself an extra bit of space. I'm going to go give myself a new page. And let's remind ourselves we've got, so n squared minus m squared, and then 2nm, and then there's this monster. Okay, so what I'm going to do is I'm going to compute the square of the magnitude of this vector. And the reason why is because I don't want to have to keep saying square root anymore. So we'll get to take the square root at the very end. Okay. So the magnitude squared. Okay, well it's going to be that squared plus that squared, and then plus, well, this monster. Okay, n squared plus m squared. Quantity squared minus 1 over 2 squared. Yeah. Okay, so first little convenience, and you probably already figured this out, but when you square this out, what you get is n squared plus m squared quantity squared. Was that cool? You want to? You're cool. Okay. So conveniently, the point is that the sort of the cross term. The cross term for, because of the minus, you're going to get minus 2 n squared m squared, but this is plus 4 n squared m squared, and that just turns the minus into a plus. Okay, cool. Stop me, anybody, if I move too fast. Okay. All right, now here I've got n squared plus m squared, quantity squared minus 1 over 2 quantity squared. Okay. Tell you what, and by the way, I haven't worked this out for a while, about a year. So I think this is going to be okay. I'm going to take this thing here, and just for momentary convenience, let me give it a name, and let's call it K. All right. Okay. So I have then K squared plus K squared minus 1 over 2 quantity squared. Now that already looks easier. Is that cool? Okay. Right, so let's multiply this out. So K squared plus, well, I'm going to have K to the 4th minus, so I'm squaring here, minus 2K squared plus 1 all over 4. All right. Okay. Now let me rewrite this k squared as 4k squared over 4. Now I've got a common denominator, and conveniently what has happened is, again, the same little sort of arithmetic bit of good fortune. This 4 is just going to turn this minus into a plus. So, kind of nice how that works out. Let's see, I guess I'll switch to orange. So I have, k to the 4th plus 2k squared plus 1 all over 4. Is that good? Yeah. Okay. And, now we recognize this is a perfect square. This is k squared plus 1 quantity squared over, 2 squared, and therefore this is k squared plus 1 over 2 quantity squared. Okay. All right, now don't forget what we were computing there was the magnitude squared. And so that means that the magnitude is k squared plus 1 over 2. K is an integer because, don't forget, k was n squared plus m squared. So that means if k is an integer, that means that k squared plus 1 over 2 is either an integer or a half integer. Yeah. Is everybody happy with how that worked out? As again, the weird little sort of algebraic coincidence showed up twice in the same calculation.
Wait, so can you go to the last part? Why does it have to be an integer?
Yeah, so what we have here is an integer that's divided by 2. There's only 2 cases, right? That integer is either even, in which case dividing it by 2 makes it still an integer, or it's odd, in which case it's a half integer. Everybody happy? Okay, let me stop that recording.